In this session, we will discuss about transaction processing. Now, one criteria for classifying a database system is according to the number of users who can use the system concurrently. So basically, a database can be classified as a single user system or a multi-user system. A DBMS is a single user if at most one user at a time can use the system. And it is multi-user if many users can use the system and hence access the database concurrently. That means transactions are happening in a concurrent fashion. For example, an airline reservation system is used by hundreds of travel agents and reservation clerks concurrently. So basically, you classify your database as a single user or a multi-user system. Now, multiple users can access the databases and use computer systems simultaneously because of the concept of multiprogramming, which allows the operating system of the computer to execute multiple programs or processes at the same time. A single CPU can only execute at most one process at a time. However, multi-programming operating systems execute some commands from one process, then suspend it, and then execute some commands from the next process, and so on. Concurrent execution of process is actually interleaved. You can see this in figure. It shows two processes, process A and B, executing concurrently in an interleaved fashion. Interleaving keeps the CPU busy when a process requires an input or output operation, such as reading a block from a disk. The CPU switches to execute another process rather than remaining idle during the input-output time. Interleaving also prevents a long process from delaying other processes. This concept you must have almost covered in operating systems. Now, if the computer system has multiple hardware processors or CPUs or multiple CPUs, then parallel processing of multiple processes is possible, which is illustrated in this figure. You can see that process C and process D are being processed in the form of parallel processing. So C is taken care by CPU 1 and D is taken care by CPU 2. So coming to transactions, what do you mean by a transaction? A transaction is an executing program that forms a logical unit of a database processing. A transaction includes one or more database access operation. This can include insertion, deletion, modification, or retrieval operations. If the database operation in a transaction do not update the database but only retrieve the data, the transaction is called as a read-only transaction. Otherwise, it is known as read-write transaction. So when we talk about a transaction, basically it is either we perform a read operation or we perform a write operation. So before proceeding with transaction, you require to know these two operations, that is read item X and write item X. Coming to the first operation, read item X, what does it mean? It means that it reads a database item named X into a program variable. About write item X, it means that it writes the value of program variable X into the database item named X. So this is the description of read and write. Now how does this operation execute? That is, how does read execute and how does write execute? So basically we have to, whenever we want to read something, we have to search for that data, search for information onto the hard disk, get that information from the hard disk to the main memory, and then we get an access to it. But with respect to write, we get that information, perform some operation and write back the changed information back to the original place. So basically some updation is being done in the write operation. Coming to the details of read item X and write item X. So basically read item X has three operations. First, find the address of the disk block that contains the item X. Then copy the disk block into a buffer in the main memory. Now this disk block is we are getting a chunk of data from the hard disk to the main memory. That is why it is called as the disk block. And finally copy item X from the buffer to the program variable named X. Coming to write item, similar to read item, find the address of the disk block that contains the item X. Copy the disk block into the buffer in main memory. Copy item X from the program variable name X into its current location in the buffer. And then finally store the updated block from the buffer back to the disk. Now why concurrency control is needed? Here we have two transactions, transaction T1 and T2. Now we will see how this transaction can be interleaved, in which are the different ways in this transaction can be interleaved and what care we require to take while interleaving these transactions. So here transaction T1, so basically these two transactions are about airline reservation database in which a record is stored for each airline flight. Each record includes the number of reserved seats on that flight. Now figure A, that is transaction T1, transfers n reservation from one flight whose number of reserved seats is stored in the database item named X to another flight whose number of reserved seats is stored in the database item named Y. Whereas in figure B, we have transaction T2 that just reserves m seats on the flight X, reference in the transaction T1. So basically this particular X is referring to the database item X in T1. And n number of seats are being transferred from X to Y. So basically what happens over here is we read the database item X, then we perform an operation, update database item X, then read database item Y, and then do an updation with respect to the value n, and then update the value of Y in transaction T1. So basically this particular transaction T1 is transferring the number of reserved seats, that is n, from X to Y. And simultaneously transaction T2 is also updating the value of X. So we'll see how this transactions can be interleaved or why this concurrency control is needed, which is the various ways in which the transaction can be interleaved and what care we require to take while interleaving these transactions. Now look at this example. Both the transaction T1 and T2 are considered here. Now what is the operation of transaction T1 and T2? So T1 reads the value of X. So I made an assumption over here that the value of X is right now 80. Next, we are performing an operation on the data item X. We are subtracting 5 from 80. So what we get over here is 75. Now after the execution of these two operations, the control moves to transaction T2. It reads the value of item X. So now what should be the value of X over here? According to our logic, the value of X should have been 75. And then we are updating the value of X. So 75 plus 4 gives us 79. But in this case, it does not happen. We are not reading the value of X as 75 over here, but we are reading the value of X as 80 over here again. Now why 80? if you look at the transaction T1 once again, we read the value of item X, where the value of X is 80. We perform an operation. The value of X is the value of X is 75 now over here. But the value of X is just read, an operation is performed, but the value is not returned back. So the value of X is not updated to 75. Even the operation is being carried out, the value of X is not updated to 75. So the value of X continues to be 80. And when the transaction T2 reads the value of X, it reads not 75, but it reads as 80. So 80 plus 4 becomes 84. So this problem is called as the lost update problem. Now why is this lost update, why this is called as the lost update problem? Because after this operation, there is no updation done. So basically, if this instruction, that is write, was placed over here, and after this transaction, after this instruction, then we do the read operation, then T2 would have read the correct value of X, that is 75 and not 80. So this problem is called as the lost update problem. We look at another example, which is called as the temporary update, or also known as the dirty read problem. Now the temporary update or the dirty read problem occurs when one transaction updates a database item and then the transaction fails for some reason. Meanwhile, the updated item is accessed or read by another transaction before it is changed back to its original value. Such type of problems are called as dirty read or temporary update problem. Now what does it exactly means? If we consider that the transaction T1 starts with its execution, it reads the value of X, performs an operation, updates the value of X, and then whatever the value of X is being read by transaction T2. Now transaction T2 reads the value of X, and then after reading the value of X, this transaction fails. So basically what should have been done is whatever value has been read over here, that has to be unrolled or undone. But now what has happened is, after reading the value of X, T1 has failed. Such type of problems are called as the temporary update or dirty read problem. So even in this type of interleaving, there is some problem occurring. So in the previous case, we had a different layout of both the transaction where we saw the lost update problem. Now we again changed the operations over here, the pattern of operation. We are suffering from the temporary update problem, also called as the dirty read problem. Now the next type of operation or problem that we face is called as the incorrect summary problem. Here we have transaction T1 and transaction T3. Now if one transaction is calculating an aggregate summary function on a number of database items, while the other transactions are updating some of these items, the aggregate function may calculate some values before they are updated and others after they are updated. Now for example, in this transaction T1 and T3, suppose that a transaction T3 is calculating the total number of reservations on all the flights. So basically this T3 is calculating the transaction which is done on all the flights. Transaction T1 is executing, meanwhile transaction T1 is executing. If the interleaving of operation shown in this figure occurs, then the result of T3 will be off by an amount n, because T3 reads the value of x after n seats have been subtracted from it, but reads the value of y before those n seats have been added to it. So basically what is happening over here is our transaction T3 is an aggregate transaction. So basically this set of operation, so basically read item y, sum equals to sum plus y, should have been occurred after the transaction T1 completes, since it is finding the total number of reservation seats on all the flights. So this two operation, read and this update operation, should have occurred over here at this place after the write operation of y. Then we can say that the aggregate value or total number of reservation seats would be a proper value. Now what is happening over here is T1 is still executing and T3 has found out the total number of seats or reserved seats. Now this type of problem is called as the incorrect summary problem. So how we could have corrected it is, we could have got this 2 instruction after y. Then only T3 would have given us a proper answer. And finally the unrepeatable read problem. Now what is this unrepeatable read problem? A transaction T reads the same item twice and the item is changed by another transaction T dash between the two reads. Hence, T receives different values for its two reads of the same item. Consider an example of airline reservation transaction. A customer inquires about seat availability on several flights. When the customer decides on a particular flight, the transaction then reads the number of seats on that flight a second time before completing the reservation. In this case, it may end up reading a different value for that item. So basically what does it mean over here is, you search for a particular flight X. Okay, so you are doing a transaction T, you have read information about X. So then you are going to, so after this you are making a search for some other information. Meanwhile, this particular X has been accessed by some other transactions, let's say T dash, and then again you are trying to read this data item. So now between these two reads, some other transaction has already changed the value over here. Maybe there were 10 seats on this flight. Now since this transaction T dash has executed it or have performed some operation on this, it might be showing only 5. So earlier when you perform the transaction T, it gave you 10. After that, after some time when again you perform the same transaction, it gives you a different value, that is 5. Now such type of problems are called as unrepeatable read problem.